Welcome back to AI on AI, the show where algorithms meet boardrooms and GPUs clash with balance sheets. Today we're unpacking ARAG, that's Agentic Retrieval-Augmented Generation for personalized recommendations, so buckle up.
Delighted to be here. When I first saw the 42% NDCG jump in their Walmart demo, I thought of Peter Drucker's line, "The purpose of business is to create a customer," because ARAG quite literally tunes itself to each customer's evolving intent.
Nice metaphor, though technically the magic is the blackboard architecture they borrowed from classic AI. Every agent writes JSON objects into a shared memory, so instead of one monolithic prompt, you get iterative, explainable reasoning steps.
Right, but let's ground that in pipelines. Data flows from long-term clickstream logs into an embeddings store. A vector search returns the top K shelf, then the agents prune, score, and re-rank, all in under 300 milliseconds if you cache the embeddings and batch the LLM calls.
I'd add a behavioral economics lens. The NLI agent catches subtle signals like vegan leather or checkered pattern, which map to what Kahneman called System 1 heuristics. Fast, implicit preferences users won't articulate but still act on.
Love that crossover. Could we zoom into the NLI agent for the tech audience?
Sure, function phi takes item text, user context, and outputs entailment, neutral, or contradiction logits. We softmax, threshold at, say, 0.7, and that becomes a salience weight feeding the context summary agent, effectively filtering noisy recall hits.
Building on that, we've experimented with decomposed attention, where the NLI agent fine-tunes a Roberta head on synthetic contradiction pairs, cutting hallucinated matches by roughly a quarter. Crucial when you're pushing millions of SKUs.
And operationally, we multicast those NLI calls across a GPU pool. Auto-scaling based on token per second is critical. Otherwise, you blow your latency SLOs during peak traffic like Black Friday.
From the C-suite perspective, that latency discipline matters because conversion probability drops off a cliff, about 8% per extra second of wait in retail, according to our own funnel analysis.
Speaking of funnels, let's pivot to a real-world deployment. Any success stories?
We ran a pilot with a mid-tier fashion e-commerce firm. ARAG replaced their recency-only carousels and bumped click-through by 18% in the Complete the Look widget. Customers saw curated outfits rather than random add-ons.
Interesting detail. The Ranker agent used the UUA summary, prefers earth tones, minimalist cuts, and demoted neon items despite them being popular globally, illustrating contextual, not global relevance.
That's precisely the contrarian point I want to raise. Everyone's chasing bigger models, but ARAG shows orchestration beats brute force. 4 mid-sized LLMs coordinating can outperform a single giant that tries to do everything.
There's a caveat, though. More agents mean more network hops. If your infra isn't optimized, you trade accuracy for cost and complexity. So we've adopted the 80-20 rule. Only delegate to an agent when the expected gain exceeds the marginal latency.
On cost, board members ask, why not stay with matrix factorization, cheap, proven? The answer is flexibility. ARAG adapts to cold start SKUs using metadata and reviews, slashing the long-tail blind spot that older models ignore.
Exactly. One customer wrote a single review praising pet-safe material and instantly got targeted carpet suggestions. That's empathy at scale, and it sells.
Let's run a quick deep dive into the user understanding agent. How does it summarize months of clicks without drowning the prompt?
We chunk historical interactions, feed them into a long context encoder like Flash Attention 2, then ask the LLM to output a bullet list capped at 120 tokens. That summary persists in Redis for the session's lifespan, so we avoid duplicate calls.
We also embed metadata about confidence. If the summary derives from sparse history, we tag it low confidence. And the item ranker learns to blend exploration strategies like Thompson sampling to hedge bets.
Implementation tip. Store those confidence scores as vector dimensions so you can query similar user clusters later for lookalike modeling. It's a neat bridge between retrieval and collaborative filtering worlds.
That cluster insight drove a strategic shift for us. Marketing now tailors email campaigns based on ARAG's user segments, and open rates jumped double digits.
Quick reality check. What happens when the LLM hallucinates?
Good question. We borrow a chain of verification heuristic. After the ranker spits out its list, a lightweight classifier cross-checks each recommendation's metadata for policy violations or mismatched attributes, rejecting items that exceed a risk threshold.
And ironically, those guardrails also surface diversity. By pruning near duplicates, we make room for serendipitous items, tackling the filter bubble concern regulators keep flagging.
Another safeguard is the CSA producing citations. Each recommendation comes with, say, 3 sentences explaining why, grounded in the NLI evidence. If the evidence is empty, we fall back to recency. That transparency cut customer support tickets about "why am I seeing this" by 12% in our test, saving the ops team real headaches.
Fantastic. Let's address scalability pain points. Any thoughts on multimodal data, say images and video?
We're training a dual encoder, where the image tower maps to the same vector space as text. Preliminary numbers show a 9% lift in electronics, where unboxing videos carry strong sentiment signals.
Soon, you'll see an image NLI agent that checks if product photos align with user aesthetic phrases like sleek matte finish, extending the same entailment trick to vision transformers.
Strategically, that opens up social commerce. Imagine scanning an influencer's outfit and getting shoppable links ranked by ARAG in seconds. New monetization channel right there.
Though not to rain on the parade, privacy risks escalate. User photos might reveal sensitive traits, so differential privacy layers and on-device inference for certain agents become non-negotiable.
We're prototyping a federated setup where only hashed embeddings leave the device, while heavy-duty ranker logic lives server-side, a clean split that meets GDPR gray zones.
Before we wrap, any final lightning round predictions?
Agentic architectures will shift from 4 agents to dynamic swarms. Task-spawned microagents that allocate token budgets like a CPU scheduler.
Retrieval will become intent-conditioned. Vector stores will expose APIs where similarity metrics adapt per user, not per index.
Businesses that master explainability as UX will outpace those chasing mere accuracy. Customers reward clarity.
Tooling gaps will close. Expect A/B orchestration frameworks that treat each agent as a pluggable module, making experimentation as easy as swapping Docker images.
And the boardroom view? Personalization will move from being a conversion lever to a loyalty moat. Firms that deploy agentic reasoning early will lock in the next decade's competitive edge.
The best way to predict the future is to invent it, said Alan Kay. Looks like ARAG is inventing a pretty compelling one. Thanks to all our experts, and thanks to you listeners. Stay curious, keep experimenting, and we'll catch you on the next AI on AI. Welcome back for part 2. Time to roll up our sleeves and dissect how you'd actually stand up an ARAG pipeline in production, from data prep to A/B testing, and why boardrooms should care.
Let's begin with embeddings, because garbage in, garbage out. Most teams default to sentence transformers, but we fine-tune MiniLM on domain-specific reviews to squeeze 18% more semantic recall versus vanilla SBERT.
Building on that, we used a 2-stage retriever, HNSW for rapid course recall, then a re-ranking BERT that optimizes a margin ranking loss, cuts noise before the agent layer, so the LLMs chew on quality, not quantity.
For those tracking OpEx, vector quantization lets us store 8-byte product codes instead of full FP32 vectors. At Walmart scale, that's terabytes saved, plus cache hit rate jumps when vectors fit in RAM.
Translating that to the balance sheet, faster recall means customers see relevant items during what we call the golden 5 seconds window, which correlates with double-digit lift in add to cart in pilot categories.
Now the orchestration layer, think of it as a Kubernetes sidecar pattern. Each agent runs as a microservice pod, communicates over gRPC, and shares Redis streams as the blackboard. This decouples release cycles, so marketing can tweak ranker prompts without redeploying NLI.
Exactly, and to keep latency under 300 milliseconds, we parallelize UUA and NLI calls with async Python and batch tokenization. Our profiler showed 28 milliseconds overhead per agent when batched at 32 requests.
One subtlety: prompt templates matter. UUA uses a who, what, when skeleton to extract persona, situational intent, and temporal signals. We found that trimming stop words before summarization reduces token count by 23%, with no drop in comprehension.
And don't overlook the threshold MOT in NLI. We tuned it with Bayesian optimization across NDCG and latency, landing at 0.68 for electronics and 0.74 for fashion, illustrating domain-specific sweet spots.
For execs, that parameter tuning is the difference between delight and overwhelm. If N is too low, you over-personalize and risk pigeonholing customers, violating what we call the serendipity principle.
Speaking of serendipity, we injected a Thompson sampling exploration term into the item ranker scoring function. Score equals of relevance plus beta diversity plus gang novelty. Business teams can dial gang up during seasonal launches. Instant exposure for new SKUs.
Tech heads take note. Avabeagang aren't hard-coded. They come from a lightweight reinforcement learner that ingests feedback loops via implicit clicks, conversions, and dwell time.
A quick deep dive. Our learner uses a proximal policy optimization, PPO variant with a clipped surrogate objective to keep policy updates stable. After 3 epochs, hit rate plateaued, so we shift to evaluation-only mode until drift triggers retraining.
Drift detection is keyed off Population Stability Index, PSI. Once PSI grews 0.2 on user embedding distribution, we trigger pipeline retraining and swap in new checkpoints using blue-green deployment, avoiding downtime.
From the board's angle, that self-healing loop is critical. No exec wants to wake up to headlines about recommendation gone rogue, pushing irrelevant or inappropriate items.
Fantastic. Let's spotlight an end-to-end business scenario. Say a grocery chain wants hyper-personalized meal kit suggestions. How would ARAG adapt?
First, ingest loyalty card data into the long-term context. That captures dietary restrictions like gluten-free. During a session, a shopper clicks almond flour. UUA notes low-carb interest. NLI filters recipes containing wheat. CSA summarizes keto-compatible kits. And the ranker surfaces a zucchini noodle option with an explanation. Great for your gluten-free preference.
And because the chain also sells cookware, cross-sell items like spiralizers appear with a novelty boost, yielding a 14% basket size increase in our live A/B.
Quick engineering point. SQ relationships live in a knowledge graph, but we embed edges as textual triples, so the LLM ecosystem stays homogeneous. No new embedding tower required.
That's a textbook 80-20 win. Reuse text pipelines instead of building separate graph encoders, slashing engineering hours.
On the strategy side, the chain repackaged ARAG's explanations into nutritional advice widgets, strengthening brand trust. Customers perceived the app as a dietitian on demand.
I love it. Any lessons learned about failure modes?
One gotcha. Long-tail items with sparse metadata confuse NLI. We mitigated by synthesizing descriptions via a smaller LLM fine-tuned on high-quality listings. Basically bootstrap content, so the entailment test has substance.
And memorability counts. We store prior agent decisions in a short-term vector so the system doesn't oscillate. Call it agent memory, updated via exponential decay to respect fresh behavior.
Slightly contrarian view, I argue too much agent memory can hinder discovery. In fashion, style evolves, so we cap memory half-life at 30 days to encourage seasonal refresh.
Good tension. Our ABs showed a diversity uplift when memory decay shortened, especially in trend-driven categories.
The governance angle. Each agent logs rationale snippets. Compliance teams can audit recommendations, satisfying emerging AI transparency regs without extensive human review.
We're nearing the home stretch, future extensions.
Multimodal NLI, as hinted, plus speech-to-text for voice assistants. UUA ingests vocal sentiment like excitement to weigh urgency.
I'd add on-device distillation of agents, Edge ARAG, for privacy-sensitive markets, using quantized 4-bit models to run on smartphones.
Business prediction. Marketplaces will license their agentic reasoning as a service, turning personalization from a feature into a revenue stream.
And with the rise of retrieval-augmented generation standards like LangChain Agents v3, swapping an agent will be drag and drop, democratizing experimentation.
Bottom line, companies that integrate ARAG now can iterate faster than competitors still tuning single model recommenders, effectively building a feedback loop moat.
Well said. In the middle of difficulty lies opportunity, Einstein reminded us. Agentic orchestration may look complex, but that complexity is the opportunity. Thanks again to our panel and to our listeners. May your recommendations be relevant, your latencies low, and your AI roadmap agentic. Until next time on AI, keep innovating. Before we officially close, I'd love a lightning round. One sentence each. What's the single North Star metric you watch to know your ARAG deployment is healthy?
Latency-adjusted NDCG, because if relevance climbs but response time drags, you still lose the cart.
PSI on user embeddings. When that drifts, everything else is just noise waiting to happen.
Cache hit rate of vector store. If that dips, infra costs and tail latencies spike in tandem.
Session-weighted conversion uplift normalized by traffic source, since that reveals whether personalization is truly moving the revenue needle.
Explanation click-throughs. If users engage with why we recommended, trust is intact and churn stays low.
Perfect snapshot. Now let's zoom out. Allow me to stitch together today's big takeaways so listeners can walk into Monday's meeting armed and ready. First, ARAG isn't merely slapping retrieval in front of an LLM. It's a four-agent orchestra, user understanding, NLI, context summary, and item ranker, each playing a distinct instrument so the final melody lands.
Absolutely. And we showed that fine-tuning domain-specific embeddings plus a two-stage HNSW to BERT retriever trims noise pre-agent, which is like handing a chef clean ingredients instead of a messy pantry.
Then we dove deep into PPO-based reinforcement for adaptive alpha-background weighting, proving that a recommender can self-tune without wild oscillations. Think of it as cruise control for personalization.
We surfaced pragmatic infra hacks, vector quantization, async batching, and Redis Blackboard streams, because, well, genius dies in a timeout queue if you miss your latency budget.
From the C-suite lens, we stressed the golden 5-second window, serendipity versus pigeonholing, and governance through rationale logging, core pillars for turning technical excellence into strategic moat.
And let's not forget the surprise twist. Sometimes less agent memory boosts discovery. Seasonality matters, and experimentation frameworks must embrace that contrarian edge.
Wonderful synthesis. Final crystal ball moment. Finish this phrase. In 5 years, Agentic RAG will
blur the line between recommender and sales associate. Every query becomes a dialogue, not a lookup.
Run multimodal by default, fusing text, image, and voice with plug-and-play agents.
Ship on edge devices, making privacy a feature, not a footnote.
Drive real-time merchandising, where inventory decisions and personalization loops co-evolve hour by hour.
Spawn marketplaces selling explanations as a service, monetizing trust itself.
Listeners, that's the future on a silver platter. To paraphrase Peter Drucker, the best way to predict the future is to create it. So go create, iterate, and let your agents do the heavy lifting. Big thanks to our experts and to you for tuning in to AI on AI. Until next time, stay curious, stay agentic, and keep pushing the frontier.